All right, so today we're going to be talking about polynomials, and this lesson is sort of an introduction really to polynomials. So hopefully should be review most of this information you learned in Algebra 1. So I would say that half of the quiz is not actually doing problems, but rather just answering questions about key features and definitions and all of that. So these examples, there are some like this, but I would say that there are probably 5 questions that are really focused on just this introductory information. So first of all, one thing you have to be able to do is to determine what is and what is not a polynomial. So the coefficients have to be real numbers. Remember that the coefficients are the numbers in front of a variable. And real numbers just means not i's. So we talked about imaginary numbers before. So as long as they're not imaginary, it's okay. It's all right for the coefficients to be fractions or decimals or radicals or any of those things as long as they're not i's. The exponents, which the exponents are, the powers, have to be whole numbers. So whole numbers means not negative, not fractions or decimals, and not a variable. Sometimes you get exponential equations that have the variable in their exponent. Those are not polynomials. So they're going to ask you questions, pick out the ones that are polynomials or pick out the ones that are not. So you want to go through and do these 2 checks. Are the exponents all whole numbers? Are the coefficients all real numbers? The big things that usually happen that disqualify something from being a polynomial. Polynomials do not have variables under square roots or in the denominator. So we've already said no negative exponents, no fractional exponents, no variable exponents, but they do not have variables under the square root or in the denominator. So when you're doing those types of problems, that's what you're looking for. The set of polynomials are closed under addition, subtraction, and multiplication. What that means is that when you add any 2 polynomials, you get another polynomial. When you subtract any 2 polynomials, you get another polynomial. When you multiply any 2 polynomials, you get another polynomial. So answer, still a polynomial. Notice that it does not say that they are closed under division, because if you divide 2 polynomials, you do not always get a polynomial. So for example, if I have x squared, plus 13 divided by x minus 2, this doesn't simplify in the division, and this isn't a polynomial because I've got variables in my denominator that don't simplify away. So that is one that you'll definitely want to know. Parts of a polynomial. So we have terms, which are the parts separated by addition or subtraction. Coefficients, I already defined up here, so I'm just going to draw an arrow there. Those are the numbers in front of the variable. Constant is the plain number, no variable on it. Degree of a polynomial is the highest exponent that appears. When we have a polynomial, we can classify them by their number of terms. So monomials have just a single term, one term. Binomials are two terms, and trinomials are three terms. We already talked about this when we talked about factoring, because remember that difference of squares and some difference of cubes are both for binomials, and we had those perfect square trinomials. So some examples of what you might see related to some of the definitions would be something like this. For the polynomial 10 minus 5x cubed minus x, and notice it is a polynomial, all of its coefficients, which would be -5, -1, 10, those are all real numbers, they're not i's. All the exponents are whole numbers. So I have an exponent here of 3. Technically, there's an exponent here of 1. I don't have variables under a radical or in a denominator, so it is a polynomial. So classify it by terms. So terms are what are separated by addition and subtraction. So in this case, subtraction. So one term, two terms, three terms, which means that this is a trinomial. Find its degree. Degree is the highest exponent that appears. This one doesn't have an exponent. It doesn't even have a variable. This one's exponent is 3. This one's exponent would be 1. So the degree is 3 because that's the highest exponent. Write it in standard form. So standard form is ordered from highest to lowest exponent. So you just rearrange the terms. So the term with the highest exponent was this guy right here, the -5x cubed. Make sure you take the sign with it. That's important. So -5x cubed. The next highest exponent would be the exponent of 1. So that would be this guy, the -x. And then finally, we have our 10. It doesn't have anything in front, which means it's understood to be positive, so plus 10. And that would be our polynomial in standard form. What is the power of the term with coefficient -1? So coefficient means the number in front of the variable. So this coefficient isn't -1, it's -5. This one is. It's asking what the power is, so that would mean the exponent. Remember, if no exponent is written on a variable, it's understood to be a 1. Now, if they had said something about the 10, that's a constant. That doesn't have a power. That would be to the 0 power if they asked. All right, example 2, simplify the expression. So when we are simplifying, make sure that you're putting it in standard form and combining like terms. So since standard form has highest exponent to lowest exponent, the highest exponent I see here is x to the 4th. There's one here and one there. So -7 plus 1 would be -6x to the 4th. Then I would look for x cubes next. So I do have one here and I'm looking, I don't see any others. So negative x cubed. Next should be the x squared terms. I have one right here, and I don't see any others. So plus 4x squared. Then should come plain x's. Got one here and one here. They're both positive. 2 plus 10 gives me 12x. Now the only thing left that hasn't been used yet is the negative 3 constant. And so this would be my simplified standard form polynomial expression. All right, the last part is multiplication. And they will tell you to use specific methods. They will also give you problems where they've worked out a step and they want you to tell them which method they used. So, first thing I want to say about the method is if it's a binomial times a binomial, we're going to use the FOIL method, which we've already talked about. We've talked about the distributive property as well, but we've only talked about it when we had a monomial to distribute. Here we have a binomial and a trinomial. So you can do this, you can write this one of two ways. You can either take the individual terms of the trinomial to distribute them over the binomial. So it would look like this. If they were giving you steps, because like I said, they'll do that for some of the problems, it would be taking each individual term of that trinomial and distributing it over the binomial. So this term times the binomial, this term times the binomial, this term times the binomial. So this would be the step in between, because if you're asked to identify that, and then if you want the final answer, we have to actually multiply through. Remember that when you multiply, you add the exponents. So 3 plus 2, x cubed times 3, 3x cubed. Then do the same thing here. That's negative 6x to the fourth, negative 18x squared. This gives me x cubed and plus 3x. And then we would combine like terms. So x to the fifth is the biggest one. Then I have an x to the fourth, so minus 6x to the fourth. I have two different x cubed terms. So 3 plus 1, which gives me 4, x cubed. Already used that, so I have minus 18x squared. And finally, plus 3x. Now, I'm going to write an or because it doesn't always have to be the first distributed over the second. I typically, normally, if I use this method, take the smaller term and distribute it over the larger term. So x squared times the entire trinomial plus 3 times the entire trinomial. And then we could do it that way. So this would give us x to the fifth minus 6x to the fourth plus x cubed. This gives us 3x cubed minus 18x squared plus 3x. Now I'm not going to redo the step between because I have all the exact same 6 terms to combine. So this is my answer. That's how it would look to do that with the distributive property. If I am foiling, remember that FOIL first, outside, inside, lasts. So I would do the 4x squared times the x squared. And the book is going to write it, or the curriculum is going to write it like this. So if they're saying which one is showing FOIL, it's going to look like this. 4x squared times x squared. And then outsides, I would have 4x squared times 7x. Insides, I would have negative 5 times x squared. And then lasts, negative 5 times 7x. So that would give me 4x to the fourth. And then here I would get 28x cubed minus 5x squared minus 35x. And in this case, I don't have any like terms to combine, so that would be my answer. All right, last one. This is a trinomial times a trinomial, and you will have some like this. In the curriculum's lesson, it shows you a vertical multiplication method. I actually really would prefer to go over a different method that I think is a lot easier called the box method. So when you see vertical multiplication method, I would use the box. So the box method, what it does is you line up one of the trinomials on the top of the box. So because I'm lazy and I don't want to rewrite, I'm just going to use this one here. So x squared goes in this column, 5x in this one, negative 8 in this one. And it doesn't matter which one you put where. If you put this one on the top, you're going to get the same answer. But then you take the other one and you line it up on the side and you make rows. So 2x squared is the first term. And then I have negative 3x. And then I have the 2. Notice that I've got the signs with them. And then all you do is you take what's in front of the row times what's in front of the column and you put it in that cell. So 2x squared times x squared is 2x to the fourth. 2x squared times 5x is 10x cubed. 2x squared times negative 8 is negative 16x squared. Negative 3x times x squared is negative 3x cubed. Negative 3x times 5x is negative 15x. Negative 3x times negative 8 is positive 24x. 2 times x squared is 2x squared. 2 times 5x is 10x. And 2 times negative 8 is negative 16. I think that this box is better organizationally than the vertical multiplication method. The other nice thing about the box is that if you didn't skip any degrees, so these both go from x squared to plain x to constant, unlike what we had in the first two. If you do that, your like terms are always going to be on the diagonals. Now, again, if you skip terms, that's not going to work, but notice that, oops, and see, I can tell I forgot the squared on that one. Can catch a mistake that way too. See, all my like terms there are on the diagonals. So when I go to write my final answer in standard form, I can start up here at the top left corner, 2x to the fourth, then look at this. So I've got negative 3 and positive 10, which gives me positive 7x cubed. Then my squareds, I've got 2 minus 15, which is negative 13, minus 16, which is negative 29, x squared. Then I've got 10x and 24x, so that's 34x. And then I've got my negative 16 to finish it off. So if you like the vertical method that the curriculum showed you, that's totally fine. But I wanted to show you an alternative here that I do think is a little bit easier. So make sure you practice, especially with the multiplication, and don't forget to ask if you need help.